Let's dive right into this explainer. Today, we're tracking the ultimate engineering quest, building a device that honestly sounds like pure science fiction. We are talking about a massive mechanical eye that can see the universe 15 times sharper than the famous Hubble Space Telescope. It's called the Extremely Large Telescope, or ELT, and it's going to allow us to see distant planets a staggering 5,200 times closer than our own eyes ever could.
To understand how they're pulling this off, we first have to cross into Chile's Atacama Desert. Second only to Antarctica, this is literally the driest place on the planet. It's a brutally hostile landscape filled with volcanoes, vast salt flats, and dense fogs. In fact, there are parts of this desert that haven't seen a single drop of rain in recorded history. It's so alien out there that the European Space Agency actually uses it as a testing ground for their Mars rovers.
So you're probably wondering, why build here? It seems completely impossible, right? The European Southern Observatory is building this colossal scientific instrument 10,000 feet up on a mountain peak called Cerro Armazones. That is 1,300 kilometers away from the capital of Santiago and 130 kilometers from the absolute nearest city. When they started, there were no roads, no electricity, and zero water.
Well, the payoff for all that isolation is absolutely crucial. Unparalleled darkness. If you build anywhere near a city, light pollution just totally ruins the faint light of distant stars. Plus, the Atacama's crazy high elevation pushes it right above most atmospheric moisture. That gives astronomers 320 completely cloudless days every single year. It's basically a permanently clear window straight into the cosmos.
And the sheer scale of the ELT it totally dwarfs current megastructures. To protect the delicate mirror from even a single speck of dust, it has to be enclosed inside this massive steel dome with giant doors. To put it in perspective, this dome is taller than the Statue of Liberty, covers the exact footprint of an Olympic football field, and weighs as much as 2,400 pickup trucks. And the whole shebang sits on a high-tech platform that can smoothly rotate 360 degrees.
Naturally, building a structure 40% taller than the Leaning Tower of Pisa out in a completely barren wasteland comes with a pretty monumental price tag. The estimated cost of the ELT? A cool $1.6 billion. That is roughly equivalent to the entire budget needed to construct the Burj Khalifa, literally the tallest building in the world. But as you might guess, conquering this mountain has been a grueling, decades-long road of trials. After testing various sites back in 2010, they finally picked this jagged peak. But here's the catch. You can't exactly build a massive, ultra-precise telescope on a pointy rock. You need a perfectly flat surface.
So, how do you get a flat surface the size of 7 football fields on top of a mountain? You literally blow the top off. In 2014, the engineering team drilled deep holes, packed them with heavy explosives, and just detonated the peak, shaving off 100 meters of solid rock. They cleared out enough dirt and stone to fill 1,911 Olympic swimming pools. It's just wild.
But here's where things took a crazy turn. Those massive explosions worked, but they actually damaged the mountain's rocky core. Deep underground cracks formed, and for the next 5 years, these massive sinkholes would just spontaneously open up and swallow the ground. The team literally had to bring in heavy vibration drills to artificially shake the earth until all the potential sinkholes collapsed, finally stabilizing the site.
Okay, but the challenges didn't stop there. The Atacama is a highly active seismic zone. Earthquakes happen all the time. So to protect these multi-million-dollar optical instruments, the telescope's foundation was built completely separate from the dome's foundation. They installed these advanced hydraulic shock absorbers in between them. So even if a violent earthquake hits, the tremors never reach the delicate mirrors. They finally finished this incredible foundation in 2023.
Now, let's talk about the absolute heart of this facility, the primary mirror. This thing is a staggering 39 meters across. Because you obviously can't transport a single piece of glass that big up a mountain, they built it from 800 individual hexagonal pieces. They fit together exactly like a giant puzzle, making a mirror 4 times larger than any existing telescope on Earth.
To really understand its power, get this. That 39-meter mirror can gather 100 million times more light than your own eye. 100 million. Out in the pitch-black sky of the Atacama, this mind-bending light-gathering power is exactly what's going to let astronomers peer into the deepest, darkest corners of the universe.
But honestly, just gathering light isn't enough. Our Earth's atmosphere naturally blurs starlight, which is actually why stars appear to twinkle. To fix this, the ELT uses a system straight out of sci-fi. The light bounces from the main mirror to secondary mirrors, And then, the telescope fires powerful laser beams 90 kilometers straight up into the sky. These lasers excite sodium atoms in the upper atmosphere, making them glow to create literal artificial guide stars.
By instantly analyzing how our atmosphere blurs those fake stars, the telescope does something totally mind-blowing. A specialized mirror physically changes its own shape, morphing and warping in real time to perfectly cancel out the atmospheric distortion. This is called adaptive optics, and it gives us an image of unprecedented, crystal-clear sharpness.
So, with the mountain conquered, the earthquakes neutralized, and the optics perfected, we finally reached the ultimate vision of the ELT. It isn't just a telescope, it is quite literally a time machine. Now you might be wondering, how exactly does a giant mirror let us look back in time?
Well, it all comes down to the cosmic speed limit. Because light takes time to travel across the vastness of space, looking further out literally means looking further back into the past. Just like how sunlight takes 8 minutes to reach us, meaning we always see the sun as it was 8 minutes ago. While the famous Hubble Space Telescope can capture light that's been traveling for 13.4 billion years, the ELT pushes that boundary even further. It can peer 100 million years deeper into the past. Since the Big Bang happened 13.8 billion years ago, the ELT is going to capture the faint light of the universe's very first galaxies, forming just 300 million years after the universe began.
But beyond actual time travel, the ELT is going to completely revolutionize our search for life. Instead of just watching stars dim, it will actually photograph exoplanets directly. Scientists will be able to check their atmospheres for water, oxygen, and incredibly, signs of alien pollution. Chemicals that indicate an industrialized civilization. Finding that would fundamentally change how we view our entire existence.
When it opens its massive eye in 2029, the extremely large telescope is going to redefine our place in the cosmos. By overcoming just impossible engineering odds in the harshest desert on Earth, humanity is turning the greatest mysteries of space into observable science. It is absolutely our best chance to answer that age-old question, are we alone in the universe?
If that eye eventually stares back at an industrialized alien world, how will that change humanity forever? Definitely something to think about. But hey, while we're building megastructures to look up at the stars, our own planet is doing something unbelievable right beneath our feet. Join us next time on The Explainer as we dive into the massive cracks in Ethiopia that are literally tearing an entire continent apart to birth a brand new ocean. You really won't want to miss it.